For thousands of years, people have looked at the sun as the source of life on Earth. It gives us light, warmth, and the energy that makes our planet habitable. Every sunrise reminds us of its importance. But what if the same star that makes life possible also has the power to disrupt modern civilization? It may sound surprising, but scientists have spent decades studying a hidden threat that doesn't come from Earth at all. It comes from nearly 93 million miles away, on the surface of the sun. The sun is far from being a quiet ball of fire. Deep inside, enormous forces are constantly at work. Powerful magnetic fields twist, collide, and build up incredible amounts of energy. Most of the time, these changes happen without affecting our daily lives.
But occasionally, that energy is released in an explosive event unlike anything humans can create. These eruptions are known as solar storms. Some solar storms are relatively small and pass by with little effect. Others are powerful enough to send massive clouds of electrically charged particles racing through space at extraordinary speeds.
If one of those clouds is directed toward Earth, it can interact with our planet's magnetic field and trigger what scientists call a geomagnetic storm. This is not a theory. It is a natural phenomenon that has been observed and recorded many times throughout history. In fact, space agencies such as NASA and NOAA continuously monitor the sun every day, tracking solar activity and issuing forecasts whenever significant eruptions occur. Why?
Because modern society depends on technologies that can be influenced by space weather. Communication satellites, GPS navigation, radio systems, aviation, and electrical infrastructure all operate in an environment connected to space. Understanding solar activity helps scientists and engineers prepare for periods of increased solar activity and reduce potential disruptions. One historic example still attracts the attention of researchers today.
In 1859, astronomer Richard Carrington observed an enormous solar eruption. Shortly afterward, Earth experienced the most powerful geomagnetic storm ever recorded, now known as the Carrington event. At the time, telegraph systems across parts of North America and Europe experienced significant disruptions. Operators reported electrical surges, and spectacular auroras appeared much farther south than usual.
The world of 1859 was only beginning to use electrical communication. Today's world is far more connected. That is why scientists continue studying how future extreme solar storms might affect modern technology, and how better forecasting can help protect critical systems. Fortunately, Earth has a strong magnetic field that provides important natural protection, and engineers continue improving the resilience of satellites and power networks. Even so, the sun remains one of the most powerful objects in our solar system, and there is still much we are learning about its behavior. So, the real mystery isn't whether solar storms exist. We know they do. The question is, if an extreme solar storm, similar to the Carrington event, occurred in the modern era, how would America respond? And are we truly prepared for it?
To understand how a solar storm could affect Earth, we first need to look at what is happening on the surface of the sun. The sun is not a calm, steady sphere. It is an enormous ball of superheated plasma, where temperatures reach thousands of degrees on the surface and millions of degrees in its outer atmosphere. Beneath that glowing surface, powerful magnetic fields are constantly twisting, stretching, and colliding with one another.
As these magnetic fields become unstable, they can suddenly snap and reconnect, releasing an extraordinary amount of energy in just a few moments. This explosion is called a solar flare. Sometimes, a solar flare is accompanied by something even larger, a coronal mass ejection, or CME. A CME is a gigantic cloud of plasma and magnetic energy launched into space. It can contain billions of tons of charged particles traveling at millions of miles per hour. Most CMEs miss Earth completely because they are ejected in different directions. But when one is aimed directly at our planet, scientists begin watching very closely. Fortunately, Earth is not defenseless. Our planet is surrounded by a magnetic field called the magnetosphere. It acts like a giant invisible shield, deflecting much of the charged energy coming from the sun. Without this natural protection, life on Earth would face a much harsher environment. When a powerful CME reaches Earth, it doesn't strike the ground like a meteor. Instead, it collides with a magnetosphere, creating what scientists call a geomagnetic storm. These storms can produce spectacular displays of the northern lights, known as the aurora borealis. During strong solar activity, these colorful lights can sometimes be seen much farther south than usual, creating breathtaking scenes across parts of North America. But alongside this beauty, geomagnetic storms can also create challenges for technology. Strong disturbances in Earth's magnetic field can interfere with satellite operations, radio communications, GPS accuracy, and some power transmission systems. Airlines flying near the polar regions may occasionally adjust their routes during periods of intense solar activity to reduce communication disruptions. This is one reason why organizations such as NASA, NOAA, and the Space Weather Prediction Center monitor the sun around the clock. Using satellites and advanced instruments, scientists can often detect major eruptions and provide advance warnings before their effects reach Earth. Although forecasting has improved dramatically over the past few decades, predicting the exact strength and impact of a solar storm remains a complex scientific challenge. Every eruption behaves differently. Some pass with almost no noticeable effects. Others remind scientists just how dynamic and unpredictable our nearest star can be. As technology becomes more advanced and more connected to satellites and electrical systems, understanding space weather is becoming increasingly important. The sun has shaped life on Earth for billions of years. But it also reminds us that even from 93 million miles away, events in space can influence the technology we depend on every day. In the next part, we'll explore what scientists believe could happen if an extreme solar storm, comparable to the historic Carrington event, struck the modern United States. If an extreme solar storm were directed toward Earth today, it would not arrive without warning. Unlike an earthquake or a tornado, scientists can often detect major solar eruptions while they are still traveling through space. During that time, space weather experts analyze satellite data, estimate the storm's strength, and issue alerts to governments, power companies, satellite operators, and aviation authorities. Preparation is one of the biggest advantages modern society has over previous generations. When a strong solar storm approaches, satellite operators can place spacecraft into protective modes to reduce the risk of damage. Power companies may take steps to reduce stress on sections of the electrical grid, while airlines can adjust routes if necessary. Scientists also monitor astronauts aboard the International Space Station, since they are more exposed to space radiation than people on Earth's surface. Even with these precautions, an exceptionally powerful solar storm would still present significant challenges. The United States relies on thousands of satellites orbiting Earth. These satellites support weather forecasting, navigation, television broadcasting, emergency communications, scientific research, and many other services used every day. A severe geomagnetic storm could temporarily interfere with some satellite operations or communications. Engineers design many spacecraft with protective systems, but no technology is completely immune to extreme conditions in space. Electrical infrastructure is another area of concern. Large power grids stretch across thousands of miles, carrying electricity between cities and states. During intense geomagnetic storms, electrical currents can be induced in long transmission lines. Engineers have studied this effect for decades and continue improving protective equipment to reduce potential risks. Scientists emphasize that not every solar storm causes widespread disruption. Most solar activity produces only minor effects, and many events pass without noticeable consequences for the general public. The level of impact depends on several factors, including the strength of the eruption, its magnetic orientation, and how directly it interacts with Earth's magnetic field. One reason researchers continue studying solar storms is that our dependence on technology continues to grow.
From communication networks and navigation systems to weather satellites and scientific instruments, modern civilization is more connected to space than ever before. Understanding space weather helps governments and industries improve resilience and make better decisions when significant solar activity occurs. Despite the challenges these storms may present, they also reveal something extraordinary about our planet.
Earth's magnetic field has protected life for billions of years, shielding us from much of the sun's harmful radiation. Without this invisible magnetic shield, life as we know it would be dramatically different. Solar storms remind us that space is not empty or inactive. It is a constantly changing environment, where even our nearest star continues to shape conditions throughout the solar system. The sun is both the source of Earth's energy and one of nature's most powerful forces. Studying its behavior is not simply about predicting beautiful auroras or protecting technology. It is about understanding the dynamic relationship between our planet and the star that has sustained life for billions of years.
Although extreme solar storms are rare, they remain one of the most closely monitored natural hazards in space. Every day, scientists use advanced satellites and solar observatories to watch the sun, tracking changes in its magnetic activity and searching for signs of major eruptions before they reach Earth. Over the years, researchers have developed better forecasting systems, stronger satellite designs, and improved methods for protecting critical infrastructure. These advances have greatly increased our ability to prepare for severe space weather. At the same time, the sun continues to remind us that nature is far more powerful than the technology we create. Even after decades of scientific research, many questions about solar activity remain unanswered. Every new mission launched to study the sun brings us closer to understanding how our nearest star truly works. Whether the next major solar storm happens next year or many decades from now, one thing is certain. Space weather will continue to be an important part of our future. The sun has shaped Earth for billions of years, and its influence reaches far beyond the light we see every day. Understanding that connection helps us prepare for tomorrow, while revealing just how remarkable our place in the universe truly is. The sun has powered life on Earth for billions of years, but it also reminds us that space is full of powerful natural forces we are still learning to understand. Scientists continue monitoring solar activity every day, improving forecasts and developing better ways to protect modern technology. While extreme solar storms are rare, their potential impact makes them an important area of research. As our world becomes more connected through satellites and advanced technology, understanding space weather is more important than ever. The next great solar storm may be years away, or it could arrive sooner than we expect.
What if I told you James Webb just revealed something that could change everything we know about the universe? For decades, astronomers believed the early universe was simple, dark, and mostly empty. But then, the James Webb Space Telescope looked deeper into space than ever before, and what it found shocked scientists. Webb detected massive, fully formed galaxies that appear to have existed far earlier than many current models predicted. These galaxies seem too large and too evolved for such an early stage of the universe. Because light takes billions of years to reach us, looking farther into space is like looking back in time. That means James Webb is showing us the universe as it existed billions of years ago. Some of these observations are encouraging scientists to re-examine parts of our understanding of how galaxies formed. Could our current theories need updates? Or are there cosmic processes we haven't discovered yet? James Webb isn't proving that everything we know is wrong, but it is opening new questions that astronomers are actively investigating. Every new image from Webb reminds us that the universe is far more mysterious than we imagined. The greatest discoveries may still be waiting in the darkness. What if everything we know about the universe is incomplete? James Webb discovered ancient galaxies that shouldn't exist so early, forcing scientists to rethink how our universe may have truly begun.
These galaxies appear surprisingly massive and mature for such an early point in cosmic history. Because James Webb looks billions of years into the past, every observation challenges scientists to test and refine existing theories. The telescope isn't rewriting science, it's revealing mysteries that could reshape our understanding of the universe.
As researchers continue analyzing James Webb's data, they're uncovering objects that formed only a few 100 million years after the Big Bang. Some of these galaxies contain far more stars than scientists expected, raising new questions about how quickly the early universe evolved. While these findings don't disprove the Big Bang, they suggest parts of our current models may need refinement. That's how science works. New evidence leads to better understanding. With every deep space image, James Webb pushes the limits of human knowledge, reminding us that the universe is still full of hidden secrets waiting to be discovered, beyond the reach of our imagination.
What if everything we know about the universe is incomplete? James Webb discovered ancient galaxies that shouldn't exist so early, forcing scientists to rethink how our universe may have truly begun.
These galaxies appear surprisingly massive and mature for such an early point in cosmic history. Because James Webb looks billions of years into the past, every observation challenges scientists to test and refine existing theories. The telescope isn't rewriting science, it's revealing mysteries that could reshape our understanding of the universe.
As researchers continue analyzing James Webb's data, they're uncovering objects that formed only a few 100 million years after the Big Bang. Some of these galaxies contain far more stars than scientists expected, raising new questions about how quickly the early universe evolved. While these findings don't disprove the Big Bang, they suggest parts of our current models may need refinement. That's how science works. New evidence leads to better understanding. With every deep space image, James Webb pushes the limits of human knowledge, reminding us that the universe is still full of hidden secrets waiting to be discovered, beyond the reach of our imagination.
Scientists expected darkness, but James Webb found ancient galaxies shining far too soon. If these observations are confirmed, they could transform how we understand the universe's earliest moments forever. Scientists thought they understood the early universe until James Webb looked deeper than ever before. Instead of finding tiny, newborn galaxies, Webb spotted enormous, fully developed galaxies that seemed to exist far too early after the Big Bang. The discovery stunned astronomers and sparked new debates across the scientific community. Are our current models missing something important? Or did galaxies form much faster than anyone imagined? James Webb hasn't proven that everything we know is wrong, but it has revealed mysteries that scientists are racing to solve. One telescope is rewriting our questions about the origins of the universe. What if the oldest galaxies in the universe are breaking the rules of modern science? For decades, astronomers believed they had a solid understanding of how the universe evolved after the Big Bang. Tiny clouds of gas slowly formed the first stars, then small galaxies, and eventually the giant galaxies we see today. It was a logical timeline, until the James Webb Space Telescope looked deeper into space than any telescope ever had. What it found surprised scientists around the world. James Webb has detected massive galaxies that already appear fully formed only a few 100 million years after the Big Bang. According to many existing models, galaxies that large and mature shouldn't have had enough time to develop. Because light takes time to travel, every distant object Webb observes is actually a snapshot from the ancient universe. Looking farther into space means looking farther back in time. In some cases, James Webb is showing us light that has traveled for more than 13 billion years before reaching Earth. The surprising part isn't just that these galaxies exist, it's how advanced they appear. Some contain enormous numbers of stars packed into structures that seem far older than scientists expected for that point in cosmic history. Researchers are now carefully analyzing these discoveries using spectroscopy, a technique that studies light to estimate the distance, composition, and age of galaxies.
While some measurements are still being refined, the observations are encouraging astronomers to test and improve existing theories about galaxy formation. Importantly, James Webb has not disproven the Big Bang. Instead, it is providing new evidence that may help scientists better understand what happened in the universe's earliest moments. This is how science progresses. New observations lead to better models and deeper understanding. Every major discovery raises new questions. How did these galaxies grow so quickly? Were stars forming much faster than expected? Or are there physical processes in the early universe that researchers have not yet fully understood? Scientists around the world are working together to answer these questions, and every new Webb observation adds another piece to one of the greatest puzzles in astronomy. What if the universe has been hiding a secret that could transform everything we thought we knew about cosmic history? After the Big Bang, tiny clouds of hydrogen and helium slowly collapsed under gravity. The first stars ignited, small galaxies formed, and over billions of years, those galaxies merged into the enormous cosmic cities we see today. It was one of the strongest ideas in modern astronomy. Then, the James Webb Space Telescope looked farther into space and farther back in time than any observatory in human history. What it found left scientists asking brand new questions. Because light travels at a finite speed, every object James Webb observes is a glimpse into the distant past. Looking billions of light years away is like opening a window into the universe just a few 100 million years after the Big Bang. Astronomers expected to find tiny, young galaxies, still in the earliest stages of growth. Instead, Webb discovered galaxies that appear surprisingly massive, bright, and well-developed. Some seem packed with billions of stars far earlier than many existing models predicted. The discovery doesn't mean science was wrong. It means nature may be more complex than we imagined. Scientists are now carefully studying these galaxies using spectroscopy, a powerful technique that analyzes light to estimate a galaxy's distance, chemical composition, motion, and age. As more data becomes available, researchers are refining their measurements and testing new explanations for how these enormous structures formed so quickly. Several possibilities are being explored. Perhaps stars formed much faster in the young universe than expected. Maybe galaxies merged together at extraordinary speeds. Or perhaps physical processes that shaped the first galaxies worked differently during the universe's earliest moments. Every new observation helps scientists improve their understanding. Importantly, James Webb has not disproven the Big Bang theory. Instead, its discoveries are helping astronomers refine models of galaxy formation and better understand the universe's first few 100 million years. That's exactly how science advances. Every unexpected discovery leads to better questions, stronger evidence, and more accurate theories. The James Webb Space Telescope is doing far more than taking beautiful pictures. Its giant gold-coated mirror collects incredibly faint infrared light that has traveled across space for more than 13 billion years, allowing humanity to observe some of the earliest chapters in cosmic history with unprecedented detail. Each new image reveals galaxies, stars, black holes, and mysterious structures that were completely invisible to previous generations of telescopes. With every observation, Webb reminds us that the universe is still filled with mysteries waiting to be explored. Some answers may confirm what scientists already believe. Others could reveal entirely new chapters in the story of cosmic evolution. And that's what makes this mission so extraordinary. We are witnessing discoveries in real time. Discoveries that future generations may one day read about in history books. One thing is certain. The deeper James Webb looks into the universe, the more it reveals that space is far stranger, more beautiful, and more mysterious than anyone ever imagined. And somewhere in that endless darkness, the next discovery may be waiting to change everything. But the mystery doesn't end with ancient galaxies. James Webb has also detected surprisingly bright objects, massive star-forming regions, and distant structures that seem to have evolved far faster than many scientists expected. These discoveries are encouraging astronomers to re-examine how the first galaxies grew during the universe's earliest era. One possibility is that the first generations of stars formed at an incredible rate, producing galaxies much more rapidly than current models predicted. Another idea suggests that early galaxies merged together more efficiently, creating large cosmic structures in a surprisingly short amount of time. Researchers are actively testing these possibilities, using new observations and advanced computer simulations. What makes James Webb's discoveries even more remarkable is that every answer seems to uncover an even bigger mystery. Beyond ancient galaxies, Webb has detected extremely distant black holes, unusual star clusters, and faint galaxies that challenge our understanding of the early universe. Some of these objects appear to have grown much faster than scientists once believed was possible. Astronomers are now exploring whether the conditions after the Big Bang were more favorable for rapid galaxy formation than previously thought. Others are investigating whether hidden processes, still unknown to modern science, helped shape the universe during its earliest moments. Every new observation is carefully compared with data from other observatories, allowing researchers to test ideas with greater accuracy than ever before.
James Webb isn't rewriting the laws of physics overnight. Instead, it's providing the most detailed view of the young universe humanity has ever seen. With each new image, scientists gain another clue in the search to understand where galaxies, stars, and even our own cosmic origins came from.
The deeper Webb peers into space, the more it reminds us that the universe is still full of unanswered questions. And somewhere in that endless darkness, the next discovery could reveal a chapter of cosmic history we've never imagined before. Every new transmission from James Webb reminds us that the universe is still writing its own story. What once seemed impossible is now becoming a new frontier of discovery. The greatest cosmic secrets may still be waiting, hidden in the darkness, billions of light years beyond our reach. As James Webb continues exploring the deepest corners of space, every observation brings humanity closer to understanding our cosmic origins. The universe has guarded its secrets for billions of years, but now, for the first time, we're beginning to unlock them, one extraordinary discovery at a time. What if the universe has been hiding something that shouldn't exist? For decades, scientists believed they had a reliable timeline for how the universe evolved after the Big Bang. Tiny clouds of hydrogen gradually formed the first stars, those stars gathered into small galaxies, and over billions of years, those galaxies slowly grew into the enormous cosmic cities we see today. Then James Webb looked deeper than any telescope in human history. And suddenly, that timeline didn't seem so certain anymore. Using its powerful infrared instruments, the James Webb Space Telescope has detected galaxies that appear astonishingly massive, bright, and surprisingly mature only a few 100 million years after the Big Bang. According to many existing models, these galaxies simply shouldn't have had enough time to become so large. Because light travels at a finite speed, every distant galaxy is actually a message from the past. When James Webb observes objects more than 13 billion light-years away, it's showing us the universe as it existed near the beginning of cosmic history. But the biggest surprise isn't just their age, it's how developed these galaxies already appear. Some contain billions of stars packed into organized structures, suggesting that galaxy formation in the early universe may have happened much faster than researchers once believed. Scientists are now carefully studying these discoveries using spectroscopy, which reveals a galaxy's distance, chemical composition, and physical properties with remarkable precision. These observations are encouraging astronomers to test long-standing theories in entirely new ways. Some researchers believe the first generations of stars may have formed at extraordinary speeds, rapidly building galaxies far earlier than expected. Others suggest frequent galaxy mergers could have accelerated their growth. There are also ideas involving hidden physical processes that scientists are only beginning to investigate. Importantly, James Webb has not disproven the Big Bang. Instead, it is giving humanity the clearest view ever obtained of the young universe, allowing scientists to refine existing models with better evidence. That's exactly how science advances, not by ignoring unexpected discoveries, but by investigating them. Every new observation